2.2a is an intro to variables. So, just to warm up, let's do a couple fill-in-the-blank problems. So letter A, if we took something and added 5 to get 9, what would we have to add? Well, 4 plus 5 is 9. B, if we took 6 and multiplied it by something and got 30, well, 6 times what is 30? 6 times 5 is 30. Another way you could think about this one would be to ask yourself, 30 divided by 6 is what? Well, 5. Notice that they're the same. Letter C, 7 minus 9 is what? Well, 7 positives, 1, 2, 3, 4, 5, 6, 7, 9 negatives, 7 of them cancel out, so we're left with negative 2. Okay, so similar idea, right? We're trying to figure out what a missing or unknown value represents. So instead of filling in the blank, we're trying to find the value of each shape. So it's the same concept. We're just trying to figure out what does that shape represent? What would be in that blank? So I'm actually going to start with this middle line because I noticed that it says a triangle plus a triangle equals 8. So this means something twice equals 8. Well, I know that if I have 4 and then another 4, that would be 8. So I could say that a triangle represents 4. Well, now that I know that a triangle is 4, that's hard to see, I can fill that in on this third line. So now I know that something plus 4 equals 7. Another way to write this would be using our blanks. We could write blank plus 4 equals 7. Well, what plus 4 equals 7? 3 plus 4 equals 7. So now that we know our circle is worth 3, which means we can fill in our circle on that top line, which leaves us with a circle, or 3 plus what is 5. So again, another way to write this would be 3 plus what is 5. 3 plus 2 is 5. So we know that a square is worth 2. So what we did is we just found these 3 values. Let's try another one. Be a good idea to pause and see if you can figure out this example with our fruit. So this one's a little different because they actually started off by telling us that an apple is worth 7. So then for this second equation, I know that an apple is worth 7. So then to figure out the grapes, I'm asking myself, what equals 5 plus 7? Well, 5 plus 7 is 12. Okay, and again, I know my apple, so I can fill that in on this second equation, which says 7 equals 1 plus what? 7 equals 1 plus what? Well, 1 plus 6 would be 7. So we know that we have 3 bananas here. 1, 2, 3 bananas is 6. So what's 1 banana? Okay. Well, if we can think about this in groups, if I have 6, right? 3 groups of that, well, each group is worth 2. So a banana is worth 2. So they told us that an apple was 7. We used that to figure out that a grape is 12. And then we also use that to figure out that a banana is 2. So 7 plus 12 plus 2 would be 21. Okay, so these are examples where we were trying to figure out an unknown value. We could also use variables. So we used pictures in this shape and fruit example, and we used blanks in our warm-up problem. But let's say we used A for apple, G for grape, and B for banana. Another way to write these equations would be A equals 7. G equals 5 plus A. A equals 1 plus how many bananas? 1, 2, 3 bananas. And then A plus G plus a banana equals what? So question mark, so you can put Q for question mark. Okay. All of these letters are variables. We just use letters instead of pictures of fruit. So let's look at a couple or some vocabulary here. In algebra, we often use letters to represent unknown values. We call these variables. So again, those first couple examples, what we were doing was we were figuring out the unknown values. So when we have a blank plus 4 is 10. Well, what plus 4 is 10? 6 is. Another way to write that would be with a variable. X plus 4 is 10. Well, we know that 6 plus 4 is 10, so in this equation, x is representing 6, or x is equal to 6. So we use a variable as a placeholder for something we don't know, something that's unknown, so until we figure out what it is. So the empty space and the variable mean the same thing. We don't know this value yet. A variable can be any letter. We usually use X or Y. But again, you could use anything you want. It's just typically they use X or Y because they can. So why use a letter? It's easier to write X than drawing empty boxes or drawing our fruit. You could try and draw an apple right now. Right, there's my apple. Just writing the letter A is a lot faster. If there are several empty boxes or several unknowns, we can use a different letter for each one. Right? X is simply better than having an empty box. We aren't trying to make words with it. It doesn't have to be an X. It could be Y or W or any letter that you want to use. If you go high enough in math, you actually need more than the 26 English letters, and you start using the Greek alphabet, and things get really exciting. Okay, so now that we know a little about variables, let's review what an equation is. An equation is a mathematical sentence with an equal sign. An equal sign makes it an equation. Notice that they have that same root word, or root start of it, EQUA, right? The equal sign makes it the equation. So we could make up some examples. You could make up whatever you want. X plus Y equals 11. 2 plus X equals 7. 5 minus 2 equals 3. Those are all equations because they have the equal sign. So, when we're solving an equation, we are looking for the solution. So a solution of an equation is a value for a variable or letter that makes the equation true. So anytime we have a variable, it's an unknown. So our job is to find the solution, which really just means figure out what the unknown value is. Figure out what number would give you a true statement, would give you something that works out mathematically. So let's do a couple examples. If the given number, is the given number a solution to the equation? So letter A, we have 170 plus X equals 200. We want to know if X could equal 30. Well, we're asking if X makes this equation true or makes it make sense. So we're asking, is 170 plus 30 equal to 200? Well, 170 plus 30, if we think about 17 plus 3, that would be 20. So 170 plus 30 is in fact 200. So yes, X is equal to 30 is a solution. Is the solution. Letter B, 3 equals 12 minus A, and we want to know if A can be 6. Well, we're trying to figure out if 3 equals 12 minus 6. 12 minus 6 is 6. 3 is not equal to 6, so no. This did not make our equation true, so 6 is not a solution. Letter C, 8 times P, remember parentheses, right when the number and the parentheses are right next to each other like that, it's implied multiplication. 8 times P equals 160. We want to know if P could be 20. So we're really asking, is 8 times 20 160? Let's think about this. 8 times 2 is 16, so 8 times 20 would in fact be 160. So it made it true. It made both sides of our equation equal to each other. They're the same. That's why it's true. That's why it's equal. That is why, yes, 20 is the solution. Note that for A and C, those are the only numbers that could make that equation true or make it work out. All right, just a couple more examples here. Example 7, tell the values of the variable that make the equation true. Again, we're just trying to figure out the unknown. So m plus 6 equals 19. What plus 6 would be 19? Well, 13 plus 6 would be 19, which means that m is 13. Be a good idea to pause and try the next two. B, y times 1 equals 3. Well, what times 1 is 3? 3 times 1 is 3, which means y is equal to 3. It's our solution. Letter C, p minus 15 equals 25. Well, what minus 15 would be 25? So if I subtract it, I need something that's bigger than 25. So 25 plus 5 would be 30, plus 10 would be 40. So 40 minus 15 is 25, which means p is equal to 40. Just a couple more examples. Tell the value of the variable to make the equation true. 2/3 plus 1/5 equals h. Well, we need to figure out what 2/3 plus 1/5 is. So we need a common denominator, which would be 15. So I'm going to multiply to create my common denominator. So 2/3 becomes 10/15, and 1/5 becomes 3/15. So now 10/15 plus 3/15 would be 13/15. H equals 13/15. Two more. Letter B, we're dividing. So 3/4 divided by 1/2 equals x. So we have to divide these in order to find our unknown value. So remember, we keep, change, flip. So we keep 3/4, we change division to multiplication, and we flip 1/2 to 2/1. Okay, well, I can simplify the 2 out of here. So this would give us 3 times 1 is 3, 2 times 1 is 2. X is 3/2 or 1 1/2. All right, last but not least, we have our decimal problem. N equals 23.6 minus 5.7. So in order to find that unknown, I'm going to subtract these. So 23.6 minus 5.7, I lined up my decimals. So 6 minus 7 I have to borrow. So that would give us 16 and 2. 16 minus 7 is 9. Bring down my decimal. 22 minus 5 is 17. N equals 17.9.